So we have seen the concepts for OCL data types. Let us now go into the exercise part. The first exercise for you is to build a model for the use model that I've presented here. So you have to build a class diagram, you have to build a command list, and you have to build the example terms for the simple queries, for the advanced queries, and store the example queries and the command list and the model in a textual file. You will need this model for later exercises. The next exercise is about using parentheses in terms. So apart from using the question mark on the use command shell, you can use question mark, and this will give you a verbose evaluation. And please use this verbose evaluation to see what happens here with these terms. Next exercise, check whether these terms are pretended OCL terms, whether these terms are syntactically valid or invalid with respect to the presented class diagram for the OCL data types. Next exercise is about examples for if, then, else, and if, and you have to build terms doing some sort of conversion. Next exercise, you have to reverse a string of fixed length, and you have to build 3 syntactically different terms for this. Next exercise is you have to build a term that checks a string, whether the string represents a programming language identifier, and please be aware of that this can be nicely done with regular expressions, and if you do not know regular expressions, check on the Wikipedia what they look like and how they are used. Next exercise is about precision in formulations. Look at description A, look at description B, discuss whether one of the descriptions is more precise or whether they are equivalent. Informally discuss this. Next exercise, build a string that build an OCL expression that checks for a time format, and build an OCL term that modifies the OCL term that was checking the date format, and extend this example term to cover leap years. Next exercise, there are OCL terms with placeholders represented here, and replace the placeholders in such a way that these OCL terms become true. The OCL data types some OCL data types have the operations less, greater, less equal, and greater equal. Boolean does not have these 4 operations. Define these operations on the data type Boolean. Next exercise, construct syntactically different OCL terms that have identical evaluation. in the sense that the OCL terms yield the same result. The operations max and min are defined in OCL on real, and they are defined on integer. Is there any advantage for defining max and min again on integer, or is this redundant and without any effect? Please discuss this. Construct an OCL term such that the term uses a real, an integer, a string, and Boolean operation. So I want to see an OCL term which involves all 4 data types. Another example on constructing OCL terms that pairs of OCL terms that are equivalent. So, for example, I plus j and j plus I would always yield the same result for any I and j substituted. Next exercise is about different representations of 42. And so here are different representations of 42, here are different representations of 42 or kind of 42. Please fill in this matrix, please fill in this matrix with less and with equal, and in each position indicate whether the comparison will yield true, will yield false, or there is a syntax error that will result here in the respective position of the matrix. We started with Lassie and Jeff. We end up with Tom and Jerry. Apply your model for Lassie and Jeff for the creature class and check whether these pretended command lists would be syntactically correct for the model or not. Discuss which of the command lists here to represent what we see here on this slide most accurately. And modify your model so that this command list gets accepted without syntax errors. And the last exercise part is define additional Boolean attributes such that you get a wide spectrum, a wide range of value combinations then. And the details, you find it over here. So we started with Lassie and Jeff, and we end with Tom and Jerry, and these are the exercises for the parts on the course on OCL data types.